Hello everyone, let's look at Leetcode question 625, minimum factorization. At time of recording, this question has 125 upvotes and 111 downvotes. So the question asks, given a positive integer num, return the smallest positive integer x, whose multiplication of each digit equals num. If there is no answer, or the answer is not fit to 32-bit signed integer, return 0. Okay, so in this first example we have num is equal to 48, and the smallest possible positive integer, x, is 68, which is 6 times 8 equals 48. Example 2, num is equal to 15, smallest positive integer, x, is 3 times 5, so 3, 5, 35 equals 15. The constraints are that num is between 1 and 2 to the 31st power minus 1, or 2.1 billion approximately. Okay, running through the code. First, we define if num is equal to 1, we return 1. This just checks if the smallest factorization has already been found, we can simply return it. Next, we define answer to be 0 and base to be 1. So then we loop for I in range 9 down to 1. So we decrease the value starting at 9, so it goes for every loop 9, 8, 7, 6, 5, 4, 3, 2, 1. Then we check while num modulus I is equal to 0. This just checks if we have found a valid factorization integer. If we have found one, we can then divide it by number. So then number divided by this I will be the first value that we can add to answer. So answer becomes base times I plus answer. Base initially starts at the value 1, and this just means the tens place. So we add a value to the tens place and place it into answer, and then modify base to move the decimal place 1 to the right. So it becomes the hundredths place, and so on. Finally, we return answer if num is equal to 1 and the answer is less than this maximum integer. Otherwise, we return 0 and the smallest factorization is not found. Okay, so let's run through this first example. Running through this first example, so we have num is equal to 48. Okay, so we start at range 9, while num 48 modulus 9 is not equal to 0, so we loop back, decrementing by 1. So I becomes 8, and we check again, is num modulus 8 equal to 0? Let's see, 48 modulus 8 is 0. There is no remainder, so then num becomes 48 divided by 8. So 48 divided by 8 is 6. Nums becomes 6. Okay, nums equals now 6. Then answer is equal to base times I, 1 times 8, plus answer 0. So answer is now 8. So for the ones place, we have added 8 as the answer, and then base times 10 means that we are now moving to the hundredth or the tenths place. So then we loop once more, and we check if nums is modulus I equal to 0. So 6 modulus 7 is not 0. 6 modulus 6 is 0. Okay, sweet. That means then we can enter this while loop. Nums divided by 6. Okay, 6 divided by 6 is 1. So nums now becomes 1. And answer is equal to base times I. So base is now 10. So 10 times 6 is 60. And then plus answer is 8. So answer becomes 68. Okay, and now that nums is equal to 1, okay, and we've looped through every single value, we will not need this modulus for any other value. So now we can simply return answer since num is equal to 1 and answer is less than this massive number. Okay, in this second example, we have num is equal to 15. So we first loop then for I in range 9 down to 1, 9, 8, 7, 6, 5, 4, 3, 2, 1, while 15 modulus 9 is equal to 0. This is not true, so we start the loop again at 8 now. Is num modulus, so 15 modulus 8 is not equal to 0. Okay, so 15 modulus 7, nope. 15 modulus 6, nope. 15 modulus 5, that is equal to 0. So then num becomes 15 divided by 5. So 15 divided by 5 is 3. Nums becomes 3. And then answer becomes the base value times I. So base is currently in the ones place. So 1 times 5 is 5. Plus answer is 0. So answer is 5. Then we modify the base value to the tens place now, and then we loop once more. On the remaining values we were at 5, so now for I in range 4. So is 3 modulus 4 equal to 0? No. Is 3 modulus 3 equal to 0? Yes. Okay, then 3 divided by 3 becomes 1. And then answer is equal to base times I. Remember, base is 10 now. So 10 times 3 is 30. And it's asking for 30 plus answer is 5. 5 plus 30 is 35. So answer becomes 35. Then we modify the base value, but since num is equal to 1, we do not need to iterate anymore in the loop. So then we return answer since num is equal to 1, and that is 35. Alright, let's check the solution here. Great. So the time complexity is actually O log num because we're dividing the number by the smallest prime factors repeatedly until it becomes 1. The number of iterations required is equal to the number of prime factors of the given number. So the space complexity is then O1 because we're using a constant amount of space to store the answer, base, and the loop variable I. That's it for this video. Thank you for watching.